I wonder if you have some sense of how robust your approach is to other bridge protocols. So if I understood correctly, this work is specific to OBS4, and I wonder if you have a sense of whether OBS4 is uniquely identifiable this way, if other bridge protocols would be more or less identifiable, what's in that direction?
Our method is especially for OBFS4 protocol. So and other protocols such as MIC, we don't take into consideration in this research. We will make the research about that in future work.
I just wonder if you have any sense of whether you think the approach in this work is generalized as well, or is each different protocol would need its own kind of unique approach? Or if you have any sense.
When we first take the experiment, we want to identify the two types of fuscation protocol, OBFS4 and MIC. But when we take the experiment, we found that we can't identify the IP address of MIC. So we just identify the OBFS4 IP address, and the features we used can identify the MIC traffic. We have proved it in our experiment, but we don't put that in this paper.
See, thank you. Hamas, you have a question?
So I was just curious about, because I've read a paper, I think it's from Roya and Safi. She works on censorship. So she basically tried to figure out how these different sensors in China or in Iraq, they basically figured out that someone was using Tor. And one of the techniques that they found out was actually there was a clear difference between the cipher suites that Tor browsers used and cipher suites that other modern Firefox, the latest updates use. That was, I think, a much more trivial way to figure out that someone's using Tor. So I was just curious about what your views are about whether detecting whole traffic patterns would be a much easier method, or whether it gets better results to detect Tor traffic.
Maybe I can try to rephrase the question, Armas, and you can let me know if I answer it correctly. Is it correct that your question is, do you have are there easier ways to detect Tor traffic than this machine learning technique? And if so, how to understand this approach in terms of those?
Basically, yeah. That's what I mean.
Sorry, we don't consider it, but it's a good suggestion, and we will discuss with my supervisor.
Okay.
I have one question, right? Just like a follow-up. So this looks like a pretty practical work, right? So do you have any plans to release some kind of artifacts, basically implementation of these algorithms that anybody can try?
Oh yes, but the code we used is not perfect, or it just can use for this paper, and I will try to post it in my page, and I will share the repository on the paper. Maybe.
Cool. Yeah, I think a community will benefit, right? Even if it's not perfect. That stopped me back at my PhD to release some code, but I should do it usually. That's advice. And as I know, actually, it's Shu is also like first paper at the conference. So yeah, congrats with that.
Thank you.
I don't see any more questions, and I know that we're.
May I just one quick remark? Sorry, I want to second what Alexi said. Don't care about code quality for research prototypes. This is not, you're not selling this stuff. You don't have to do support, but releasing things early on will allow others to work off of it, and there will be benefit. And in the best case, somebody else will help you with code cleanup and so on. So do stuff like release stuff early on itself.
Yes, thank you.
That's a good point, actually. You know, even in my case, I remember releasing something that was not well documented, and somebody else picked it up and said, "Hey, we're gonna write the documentation for you," and post it on GitHub, because it was, you know, they did it anyway. I mean, for themselves to be able to use the tool, and so you might find actually collaborators that way. So it's kind of a great thing to do if you can.
Okay, I think we're a little bit behind schedule, so I want to move to the panel discussion and see if there's any general questions that folks have for all of our presenters before jumping in. I'll start then. I think One thing that struck me is that so these are three different approaches to different ways of understanding privacy and security at the network level. I wonder what we can say in general. What we can say in general about what we think we're maybe lacking as a community in terms of research focus. So is there, should we be focusing more on the network or more on the client, or do these things compose well? Or in general, I'm wondering how the authors think we should be taking their findings for next steps.
I guess I can add to that, like to a little bit extend the question, right? So I guess like we have like these three different intersections in terms of, okay, web, but also we have, we need to think about DNS, about HTTPS, right? We need to think about scanning of IP addresses, right? And we need to think about Tor. So maybe a good answer will be if authors can say like why they chose this direction of work basically, and why they looked for problems there, right? That can answer basically where we should expect issues and where we need to look at and so on. Yeah. So paper authors, are you online? Let me see.
Maybe we could start from the top then. Maybe Ali, maybe you could say something about how you reach this topic.
Well, regarding the security of the network, I mean, the greatest network on earth, which is internet, I think that security of DNS is vital, and is something that we should take it into consideration, because DNS is currently, I mean, the vanilla DNS, or the what we call that, the DNS over port 53, which was proposed in 1987, is not pretty secure. So lots of alternatives have been proposed, and DNS over Tor is one of them, and DNS over TLS is one of them, and Cloudflare implemented something to transfer these DNS over TLS messages over Tor and make it more secure and more private, and I think anonymity to those DNS questions. So I think that they are really important. I mean, these secure DNS alternatives are playing a really important role in the future of the internet security or network security. But the point here that I want to mention is that, well, yeah, I got a bit confused about it, but yeah, there are always trade-offs when we are switching to one other tool. For example, transferring DNS over Tor, it adds lots of encryption into the DNS messages, and lots of delay time overhead would be added to the DNS ecosystem. And additionally, as one of the great audience asked a question about the DNS client-side tools, they also require lots of implementation and usability considerations in order to become more usable, to be used by the non-expert users. And that's my point. Thank you.
Thanks, Ali. Christopher, maybe you could say something about how you reached the topic and why you chose to focus in this area.
Sure. So this field it's pretty heavily cited between Shodan and Census in a lot of research, but there's not a lot of papers on how do Shodan and Census work. So there's the authors of Census did quite a good job of explaining how Census works. There's a ton of papers by Durameric, how all the tool suite. So there's the ZMap tool suite, which is all the tools they use to build Census. But there's not been a lot of work done from looking at it from the network's edge perspective. You had mentioned dark web stuff. So there was an attempt at making a Shodan-like search engine for Tor. It was called Ichidan, but it's no longer online. I found it hard to find information about it, but there is a space there to create a Shodan or Census-like internet-wide scanning service for Tor. That's one direction for future work. The other direction is the IPv6 problem. So IPv6 internet-wide scanning, it's not trivial to generate an IPv6 address that points to a valid host. There's a lot of documented, there's a man named F. Gaunt as a RFC with a bunch of ways that he suggests for discovering IPv6 hosts. But once IPv6 becomes the dominant way to communicate over the network or over the internet, it's going to be a big problem for these types of services. Another issue that they could potentially be looking at is a lot of sites are starting to use what's called SNI, so server name indication. The idea is you can host multiple websites on the same machine using the same IP address on the same port. And when a client requests the website, they have to put in the domain name in during the TLS handshake. This way, it'll redirect. So if you wanted to go to mysite.com, and then there was mysite2.com was hosted on that same machine, you would have to know that to access it. But from the perspective of internet-wide scanning, since everything's done through IP addresses, they don't know what the domain name is. So that's another potential problem that's going to have to be solved.
I think it's a great point about the better privacy gets for users, the harder it gets for researchers.
Yeah.
And it's probably a good thing in that, but bites more and more. Shri, maybe you could say something about how you found the project you worked on and why you chose to dig into this problem.
Yes, actually, the group I studied in was all focusing on the encrypted traffic analysis. That means we only focus on the attack instead of the countermeasures. So when we analyze the encrypted traffic, we based on some features of the protocols. So we never think that we can change the protocols. But maybe when we make some future work, we can focus on that because we can put forward some ideas. Maybe that won't be maybe the protocol won't change, but there may be a development trend.
Thanks, Shri. Ben, you have a provocative question.
No, it's a statement. No, the question is, I mean, is it really a problem that we can't rescan IP version 6 address space anymore? I think it's essentially it's a benefit of sorts, right? Especially considering that IPv6 is, well, depending on what router you have at home, it's routed right through you, like to your device, unless like there's a firewall, and so you'd have much more devices that could be reachable from the internet if there isn't a firewall in the way. So I think that it's not necessarily a bad thing that we can't scan IP version 6 anymore that way. Having said that, I think there are numerous ways in which you can still find hosts, like reverse DNS entries, where you can even, what's the DNSSEC NX domain, I forget what it's called, NSEC, the NSEC record. Where you can use that, right, to get like a ring, and then if you have one IP version 6 address or reverse entry, then you just find the next one, find the next one, find the next one. So that is if somebody does in fact have a DNS reverse pointer entry. So I still think it will be possible. And then the question is, let me maybe posit this after this statement, maybe another pretty provocative question. Do we need showdown and census for anything good in the sense of not finding, so I see like good in the sense of finding vulnerabilities and telling people about them first before they get exploited? Yes. Is there anything else beyond that where we definitely need scanning engines for?
So there's a couple positive use cases for it. So first, I just want to cover the IPv6 stuff that you mentioned first. So one of the issues is you're now exposing more devices that were previously protected by a NAT. I know NAT isn't intended as a security feature, but it's kind of been ad hocly used as one for a long time now, where because a device isn't directly connected, isn't visible publicly on the internet, it's not available for an attack. They'd have to have some sort of compromise on the router, or the client would have to be compromised and reach out. But in terms of, do we want Shodan and census? Well, there's lots of good use cases for it too. There's tons of papers where people have been discovering malware using Shodan and census. There's papers where they're measuring censorship use cases on the internet. There's the cases where they're identifying vulnerable devices. So there are positive reasons why we would want the internet to be scannable. And the big problem isn't that some IPv6 devices will be scannable, or will it be most IPv6 devices will be scannable? Either way, we don't have what we have now, which is all IPv4 devices can be, because the IPv4 address space is so small. Because the IPv6 is so much larger, wherever we fall on that spectrum, it's very, very unlikely that it's going to be all IPv6 addresses are scannable. So we have some shift along that scale we have to consider. So we lose the benefits of it and we lose the disadvantages of it.
So I'm currently involved in a project which is doing something really similar to this. So the preliminary results that we've gotten is that some of the scanners only basically target. So we leak some IPv6 addresses by running some services like public services like NTP and stuff.
Okay.
So we leak our IP addresses, and they know that there's a certain IP address which is present in this, let's say, a /64. So then we try to see how they come back and poke our address space to find the certain addresses in our in our allotted subspace. So what we've seen is like two different behaviors. One is a totally random scan of the whole /64 IPv6 address space, and the other is they only target the endmost nibbles. So let's say the address will have a lot of zeros and then a random digit at the end. So these are like one of the only two. These are only the two of the techniques that we've seen for now, but we still have a lot of more services to leak our addresses from. But yeah, this is a work in progress, and no one currently knows how scanners in the wild are probably doing this right now.
Another more constructive thought is also that if you are like somebody like Shodan and Census, maybe you have access to somebody with like a passive DNS data set that could also give you a lot of insight, because I mean, essentially what you were saying is, so you already leak some IPs and then you have an idea of where there might be something, or maybe even like the format, whether it's using I did forget the names. So this MAC address based IPv6 address that you use.
Yeah, the EUI64.
Yeah,
identifier. Yeah.
I mean, you can do that, or you can do like the classical. Okay, you have like zero, like ::1 at the end is your gateway, right? You could have that, and then depending on what you can see already from like DNS entries, so seed IP addresses, you could again scan. Because my gut feeling is, so I can recall the IP version 4 address of my own root server, but I can definitely not recall the IP version 6 address. So I will have a DNS entry that points to that.
That's true.
So I think still a lot of hosts will be discoverable. Not so much my smart fridge that I fortunately don't have. But then again, is it a bad thing if that doesn't get discovered? Coming back to my previous question.
So there's actually been a lot of research about how people allot these IPv6 addresses. So they try to look at the different nibble frequencies. So they see if an A is allotted, what's the probability that the next nibble would be a 1 or a 2 or a 3 till F. So that's how they generate these hit lists. And then from these hit lists, they just try to scan these host addresses and then find new addresses. So it's a whole other domain than discovering new hosts with IPv4 works. So it's more of a guesswork than it is much more.
I mean, to be, maybe again more statement than the question, but I mean, what I really worry about in IPv6 world is how representative the samples are, and in that malicious things will be hard to find and benign things will be relatively easy to find, and how to deal with that in terms of skewing results or understanding results seems at least something that needs to be on people's minds as they're doing new work.
Yeah. So I can add that from industry point of view as well, right? So this is something that we definitely working on, right? To have a different kind of malicious URL detection, right? At the end, and basically there you have like more complex systems that you have. Like, okay, in addition to IP, you have hostname, you need the proper port, you need the proper URL path, right? And proper parameters. So basically, it became very hard task, right, to scan everything and so on and so forth. So I guess like all these like ideas in terms of how to basically focus and limit the solution, you're scanning basically capacity, right? Yeah, it's super important. And completely, I second that. Finding malicious stuff can be getting harder.
They should make it easier. I think we have time for one more question before we enter the break period. Roberto, you had a question on Slack.
Yeah, so just going back to DOT, I was wondering if there is any, if you guys know of any traction with respect to deploying authoritative dot. So DOT deployed at the authoritative side, and I don't know if there is any interesting aspect even from the point of view of the analysis of certificates, like in the first talk of the session.
Well, as far as I know, I mean, as far as the documentation and standardization says, DOT has been deployed to secure a stop to recursive communication. So it's merely introduced to secure the communication between the client and the recursive resolvers. And implementing DOT between the recursive resolvers and the authoritative name servers, it's been deployed by Facebook, I guess. And, as far as I figured out, I mean, it's just my presumption. Authoritative name servers don't like overheads. And so in the second, I mean, between the recursive resolver and the authoritative name server, we don't see much plentiful of these sort of secure DNS alternatives to be used there. But yeah, that was an interesting point. And what you mentioned is an interesting point, and also implemented by Facebook. And there's a blog post about it.
As we know already, they don't like changes given the low, I guess, deployment of DNSSEC in general. It's been 2 decades already, I think. Well, almost. The DNSSEC was proposed. So in any
next
case.
year,
Say
I
again?
think next year will definitely be your DNS second year.
Yeah, maybe.
Probably year of the Linux desktop, probably, but do.